Okay, TCA, 7th grade. This is Mr. Bourgeois from the past recording this. So we're going to go through lesson 3.6, but first we're going to review lesson 3.5 because I had some students ask about how do I factor expressions with negative terms. So let's look at, let's do number 13. So number 13, we have the expression negative p and negative 2, right? This is an expression. You might be thinking negative p minus 2. However, remember, I like to think of each term as just being a term in itself. It's negative p, negative 2. I have those two things inside there. So to factor this out, if you recall, factoring is a process. We're going to take a common factor between these two. We're going to put it on the outside. We're going to put it on the outside. Oops, I forgot it makes an arrow for me. We're going to put it on the outside of a parenthetic expression. So we're going to, since we have two terms to begin with, 1, 2, separated by a plus or minus, we're going to have two terms in parentheses and then a common factor on the outside of the parentheses, okay? So what is a common factor between negative p and negative 2? Well, really, the coefficient of p is negative 1, and you might be thinking there's no common factor between the two. But sort of, kind of, there is. We can factor out a negative 1. Negative 1, and if I take negative 1 out of negative p, I'm left with positive p. And then factoring negative 1 out of negative 2, I'm left with positive 2. So this is a little bit redundant because we don't need to say negative 1 times something. So what the correct answer is they just say negative and then the quantity p plus 2. So anytime you're factoring an expression and they want you to see the curriculum wants you to factor out negatives so that hopefully all the terms aren't negative on the inside of the parentheses. I feel personally like it's a little nitpicky, but that's just the way they're doing it. Let's try another one. Let's do, let's see. They changed my whiteboard app on me, and so now I don't have my. There it is. Haha. Okay. All right. Let's try this again. I want to do another problem. Let's do number 18. Zip zip zip. So if I'm doing number 18, wake up, computer. All right, my app's not working like I want it to. So let's do number 18. And we're on page 165. So the way I do these videos is I like to let you guys have a chance to work on them yourself. And so what I often will do is, again, they changed my app, so I'm a little less familiar with it. I'll put this big pause sign up ahead. So pause the video and try to see if you can do number 18 and see what you come up with. I'll wait. Actually, I won't. So hopefully, so after you have tried number 18, hit play. Also, another comment, sometimes it can be to your advantage to listen to this video on an increased playback speed because it can just be helpful. Sometimes that makes the process a little easier to follow if I'm talking a little bit faster than my normal speech patterns. That's one of the advantages of video recordings is you can make it go faster if you need to. You can also rewind if you need to. Anyway, let me demonstrate number 18. So taking a look, number 18 says negative 4x and negative 20. You'll see again, because we have two negative terms, they're expecting us to factor out a negative. Look again, though, at the terms. We also have a coefficient of 4 and 20. Hopefully, you'll see that those have a common factor by themselves, negative or not, 4 and 20 have a common factor of 4. So 4 times 4 is 4 divided by 4 is 1, and 20 divided by 4 is 5. But beyond that, we can factor out this nasty little negative here. We like to live in a positive world, right? So let's do the factoring. Anytime I set up a factoring problem, I know I'm going to have parentheses, I'm going to have the same number of terms inside the parentheses, and I'm going to have something on the outside of the parentheses. And we said that the common factor between these two was, you all said it out loud in your screen, you said, it's 4, Mr. Bourgeois, and you are correct. So it's 4, but because we're factoring out this negative sign too, we're going to factor out -4 and not just +4. So when we factor out -4, so let me be a little different with my terminology too. When we factor out something, we're dividing it. So -4x divided by -4 equals x. So we write that there as our first term. Positive x is our first term. -20 divided by -4 is going to be +5. So this is our answer. We have to completely factor out this expression. To completely factor out this expression, we get to this. -4 times the quantity x plus 5. So that is a fully factored out expression. And this will work also with any number of terms as long as all the terms are negative. So hopefully that helps you guys with that problem. Now we're going to move on to, I'm just going to slide over. Let's move on to lesson 3.6. Open your books. You're in class now. You were in class when you started this video. Open your books to page 100 plus 50 plus 10 plus 5 plus 1. That would be 166. 166. I can't help myself, you guys. Too much fun. So on page 166, read that first page out loud. I'll wait. Okay, now I'll read it to you. You have learned to translate verbal descriptions into algebraic expressions. You can translate verbal descriptions into variable terms that have decimal, fractional, and negative coefficients, as in the following problem. Let me pause here and say, I kind of said this before. I'm not sure if I said it to everybody, but mathematics and algebra in particular give us really good tools to help understand and explain the world. So we have good tools. If I said, hey, I want you guys to put a bunch of holes in this plywood board, you could probably figure out a way to do it. But if you don't have a drill, your holes are going to be off. They're going to be difficult to make and also not very neat. And they might be all kinds of odd sizes. If you have a drill and you know how to use it, your holes will be wonderful, marvelous, and extremely useful for whatever we're doing with holes in a piece of plywood board. Algebra is a tool for helping us to find hidden, missing information, to use logical processes to find missing information. So in this expression, so let's keep reading. Amy used 2/3 of a ribbon that is y inches long to tie her hair. Write an algebraic expression for the length of the ribbon she used. So right now this lesson is not completely solving the algebra. It's giving us ways to make word problems easier. If you don't like word problems, great. You will love algebra because it gives you the tools you need to finish algebra. So as you can see, they say, okay, we're trying to express the length of ribbon, and they say that it's 2/3 of y. So we know how to change 2/3. It's 2 divided by 3. We know that of means multiply. I'll go ahead and use a big dot. And then y. Y is just y. So 2/3 of y means 2/3 times y, and we also know that we can rewrite this more simply by just putting 2/3 next to y. And please read that math note on page 166. It is very useful. 2/3 y, what you're doing when you multiply 2/3 times y, it's the same as saying 2 over 3 times y over 1, which is the same as saying 2 times y and then dividing it by 3. This kind of understanding of fractions is very useful later in life, and just useful in general. It's useful right now. It's useful always. So I want to move forward to look at the next page, example 16, where it says we're translating verbal descriptions into algebraic expressions. So let's suppose that you generally make a fruit punch recipe. It says, so we're on page 167 now, 167, example 16, by that blue box. A, it says a fruit punch. A fruit punch makes 7 quarts when used with R quarts of orange juice. Of course, why would they use any other variable except R to refer to orange juice? It's orange juice. This time it is being made with 30% less orange juice. Dag nabbit, someone got in the fridge and drank some of my orange juice. Now my punch is going to be a little less citrusy, I guess. So now write an expression for the number of quarts of fruit punch yielded this time. So in this example, they didn't reduce the other ingredients. They only reduced one ingredient. So if we have this fruit punch, I'm going to go ahead and make a bar model because just to be cheeky like that. So we have, this is the usual recipe. We were counting on there being a full pitcher of orange juice, and it was going to make 7 quarts of fruit punch. The fruit punch consists of multiple parts. There's probably some 7-Up in here, who knows. Then maybe there's some, maybe I should change colors here. Maybe there's some cranberry juice. Zzz. And maybe there's some Kool-Aid. This is the Kool-Aid. And then some quantity, we're not sure what, but some quantity is orange juice. It's our orange juice. And I'm colorblind. I'm not even sure if I did different colors for all 4 of those ingredients. But here they are. So the combined total of this is 7 quarts. There's R. And someone drank 30% of the orange juice, 30% of R. So now how many quarts do we have left? Well, the bar model is kind of the system that you've been using thus far. Now that we have a new tool of algebra, let's see if we can find another way to do this. For those of you who despise bar models, this is going to be the alternative to using a bar model. And the peasants rejoiced, so there was much fanfare. First of all, before we get there, I want to make note of that math note. Percent is written as that symbol, percent, which means out of 100, it can be written as a decimal. So 30% equals 30 hundredths, which equals 3/10. Be very careful because in a future problem, they're going to talk about 3%. 3% is not 0.3 because it's out of 100. So we want 3 hundredths. So right now here's 30 hundredths, which yes, is the same as 3/10. But so 30% got taken away, drank by your naughty little sibling or whatever, which means I only have 70% of R left. So let's take a look. So the total is going to be, I have 7 quarts and I took away 0.3 times R. 0.3 of R, and of generally means multiply. So this is how many quarts of punch I can make with the ingredients that I have. I still have the same amount of 7-Up and cranberry juice and Kool-Aid. However, my orange juice is in short supply. So sad day. It'll just be a little less orangey, a little more Kool-Aid-y. All right, turn the page. Zip. I can't help it, I have to make noise. Turn the page. We're going to do this other problem. James, it's B, problem number B. James paid X dollars plus 3% sales tax for a new pen. Write an expression for the amount of money he paid for the pen. So once again, let me show you the bar model. So here's pen price, which is X. X is for pen. Algebra, not good spellers. Let's see. And then we add 3% of, remember 3% is 300, so that's 0.03, 3% of X. And I probably drew that way too big. That looks like more than 3%, but you get the idea. So what's the total that he paid? Well, the bar model certainly helps, but if we just want to use algebra, we know that we have X. We add 2X, the sales tax, which is a multiple of X, 0.3 times X. Looking at this, remember from our previous lesson, we can combine like terms. We have two terms here. They are like because they have the same variable attached to them. They're both X terms. When I add those together, I will get 1. 1 plus 300ths is 1, and 300ths X. So the price he paid was 1 300ths X. Don't forget to label your units, dollars. And so because you are good classical students, you would write this as a complete sentence in cursive. James paid, this is really hard on a computer screen, ... $1.03, not $1.03, 1.03 times X. X was the cost of the pen. It better be a nice pen for it to be worth that much money. Who knows? I'm gonna use my lasso tool. If only I could use a lasso tool in class like that. That'd be great. I'd lasso all you students and hit mute. Okay, so pause the video and we're gonna solve. Before you pause, we're gonna solve guided practice number 1. I want you all to do guided practice number 1 together, and hopefully you will have gotten the correct answer. All right, pause the video. Do it. Do it now. What color is this? Pause the video. Zip. All right. Now that you have solved guided practice number 1, let's do it together. I'm a fan of bar models sometimes, sort of, in some contexts, sometimes. But if you are not, we can just do this with algebra. Let's read it out loud. The price of a ring was $W, which this picture of a ring is really something special. I would totally buy that ring for someone special in my life. Wendy bought it at a discount. Good for her. She bought it at a discount of 25%. Ah ha ha ha. Write an algebraic expression for the discounted price of the ring. I'm going to resist the urge to draw another bar model right now. So we have the price of the ring was W. W is for Wendy, or dollars, or ring. Come here. W. That's probably too big. Let's write smaller. W. W is the price of the ring. However, it was reduced. I'm gonna show you how to solve this in 2 ways. It was reduced by 25%. So we're gonna subtract 0.25. So 25 hundredths of, that means times, W. Once again, these are like terms because there are 2 terms. I have W and I have negative 25 hundredths W. So those 2 terms can be combined. What's 1 minus, because remember the coefficient of this is 1, what's 1 minus 0.25? The answer is 0.75 W. Dollars. Because we're in America and we use dollars. So then you would write in a complete sentence, Wendy paid 0.75 W dollars for this amazing sparkly ring thing. We're on page 169 in case you got lost. 169, guided practice number 1. So I want you students to know there's another way you can do this. If you're thinking in terms of percent, you can also do Think about it like this. If W is reduced by 25%, you know, I have 100% in a whole. 100% minus 25% equals 75%. So then if she didn't pay the full price, then that means she paid 75% of the price, which means she paid 0.75 W. Dollars. If this one was confusing for you, that's fine. I want you to know that you can go ahead and continue to solve 2, 3, and 4 in the guided practice, and I'm pretty sure the answers for all the guided practice problems are in the back of your book. You just have to find it. We're going to move forward and do one more concept before we put a bow on it and call it done. Please turn the page to page 170. Turn to page 170. We can use diagrams, models, or tables to visualize information in real-world problems. Anytime you're given a word problem, I want you to know drawing pictures is marvelous. Marvelous. Let's work through example 17. So it says John's farm has a rectangle shape. Stop right there. Okay, keep going. Its width is X yards. Its length is 6 yards more than 1/3 of its width. Write an algebraic expression for the perimeter of John's farm. Okay, so we're supposed to write an expression for the perimeter of the farm. As Mrs. Ball did on Friday, it was great. When you're reading a word problem, first read the whole word problem. You're probably not going to completely understand everything after the first reading. Now that I know that I'm looking for a perimeter, let's read it again. John's farm has a rectangular shape. Now I'm going to draw a rectangle. That looks pretty rectangular. Its width is X. Its length is 6 yards more than, okay, so 6 more than, so positive 6 plus, so 6 more means it's a positive 6. More than 1/3 of the width. Oh, 1/3 times, because times means of, the width. Okay, where's the width? What was the width? Oh, here it is. 1/3 of this. Sweet. I think I got that. The length is 6 yards more than 1/3 times width. Cool, cool, cool. This is a tiny, tiny farm. If 6 yards, I don't know. What's the perimeter? That's what we're looking for. So the length is the same on both. Who remembers how to do the perimeter? That's right, you do. So we have to add all 4 sides. So let's add them. I'm going to start on the left side. So this is X, oops, X, I'll go over here, plus X, plus 6 plus 1/3 X, plus 6 plus 1/3 X, oops. The bad part about this is if I make a mistake, I don't have you guys to raise your hand and say, Mr. Bourgeois, may I please make a correction and politely correct me. So I gotta be on my A game, or at least my C game. So noticing this, going back to a previous lesson, we remembered that if we have a whole bunch of terms, let's check to see if we can combine any of them. I see these 4 algebraic terms. I also see these 2 numeric terms. So we can always combine numeric terms. That's easy. Let's do that first. 6 plus 6 is 12. And we can combine algebraic terms as long as the variable is the same. They all have x. So we can combine them all. So I have 1x plus 1x plus 1/3 plus 1/3. 1 plus 1 plus 1/3 plus 1/3 is 2. And 2/3 x if I wanted to use improper fractions. I mean mixed numbers. Mixed numbers. So I don't like mixed numbers. I'm going to go ahead and rewrite that as an improper fraction. So 2 2/3 x is 8/3 x. 8/3 times x. So this is the perimeter in yards. He's got this many yards to walk all around his farm. And it's not yards squared because we're not doing area. It's just yards. So the perimeter of John's farm is 12 plus 8/3 x yards. Now in the book, it looks like they switched the terms around. That's fine. That's not a different answer. That's just the same answer with the terms rearranged. To make this really clear, let me move that x closer. It looks like it's kind of far away. 8/3 x. Maybe I'm being picky. At this time, I want you to do guided practice. Oops, come back here, you. Why are you not lassoing? Lasso. Oops, no, don't copy. Don't. Ah! I'll just use the eraser. Lasso tool, you're fun, but sometimes you got nothing on the good old-fashioned eraser. All right, so I want you to do guided practice number 5. As soon as you're done, so pause the video, do guided practice number 5 on page 170. As soon as you're done, unpause the video and watch me solve it. Hey, you're back, thanks. Here we go. Anne's garden has the shape of an isosceles triangle. I'm just going to go ahead and draw that now. Pretty decent. Looks isoscelic. It has a base length of 2y and sides of 2/5 y plus 3. 2/5 y plus tree on both sides. My finger is very fat. I have to write gigantic in order to make it visible. 2/5 y plus 3. Come on, plus. Let's try that again. Plus 3. Write an expression for the perimeter. Ha ha ha. Just like we did in the previous problem. We're just going to add all of these 3 things. And we're going to end up with a whole bunch of terms, and then we're going to probably be able to combine the terms, I believe. What's all this junk? Who left this on my whiteboard? All right, so we have 2/5 y plus 3 plus 2/5 y for the other side plus 3 plus 2y. So once again, I have numeric terms. I'm going to underline them, or I'm going to box them. You guys didn't know I was a boxer, did you? Now I am. So numeric terms, 3 plus 3 is 6. Haha. Now all my variables are y. Y. So I can combine all those. So 2/5 plus 2/5 plus 2. I'm going to have 2 and 4/5, which is the same as 14/5. I love improper fractions. It's just the way I roll. It's the way actually most mature mathematicians roll. Easier to keep it simple in m over n form. This is my perimeter. This is Anne's garden. It's a triangle because reasons. And yeah, it's this many feet, evidently. So then you'd write that in a complete sentence. Anne's garden has a perimeter of 6 plus 14/5 y feet. Yep. Okay, so TCA, hopefully this is all the information you need, 7th graders. Like I said, you can go back and do those guided practice problems, use the answer key in the back of the book, solve your home day stuff, and I believe you're doing all the problems 1 through 10. You should have the answers to the even problems as well in the lesson plans. If you have questions, please reach out to Mrs. Ball or me. Actually, just reach out to Mrs. Ball. I'm busy, just kidding. I'm more than happy to help you guys out. It is an honor and a privilege and a joy for me to answer your questions. So thank you again. Hopefully this was good and instructive, and you are all feeling well and being healthy. Have some fun this weekend. Love you all. Bye-bye.